Hi, welcome to Chapter 7. This is Ionic Compounds and Metals. Anything to add?
No.
Okay, Section 1 is ion formation. And ions are formed when atoms either gain or lose valence electrons to achieve a stable octet electron configuration. It's a lot of words, but really it's just they gain or lose electrons. And they're only the electrons in the outermost shell. Everything else is stable and they want to stay where they are. So the things on the outside are the ones that can move.
Okay.
So again, outermost electrons, those are valence electrons. You've heard that term many times before, especially if you've had me for Science 1. Octet,
Chapter 5.
Yeah, Chapter 5. Octet rule is when atoms gain, lose, or share electrons to fill the valence shell with 8 electrons. So it's basically all the noble gases. They obey the octet rule, and every other element wants to achieve that full octet. So the S and P sublevels are going to be full because S holds 2, P holds 6.
That equals 8.
Yes.
I can add.
Positive ions. These are called cations, not cations.
Why not?
But they're formed when an atom loses one or more valence electrons in order to attain a noble gas configuration. So your positive ions, these are typically going to be the ones on the left-hand side of your periodic table.
All the metals. Okay.
And they're going to lose electrons to look like the noble gas that is the row above them.
Yep.
Okay? They lose electrons, so they're positive charge. Good.
Positive charge.
Cation examples. So let's look at neon and let's look at sodium. Sodium is in the 3rd energy level. So if you go to the 2nd period and find neon, that is the noble gas for the 2nd period.
Okay.
So sodium wants to have its electron configuration resemble neons. So if you look at the diagrams right up here, this is sodium. It's got 3 energy levels and it's got this lonely electron hanging out here by itself. It doesn't like to be out there. It's not very stable. So sodium will lose that electron so that it ends up losing this entire outside shell and it will end up looking like neon.
Which we talked about in Chapter 6
Mm-hmm.
on the atomic radius.
Yes. So if you look at the electron configuration, if you prefer this way, you will see neon has a full S and P. It obeys the octet rule. Sodium, it has this one lonely guy that needs to go somewhere. So when you take off that one valence electron, now sodium is going to have a +1 charge.
All right. Okay.
All right.
Sounds good to me.
Now let's talk about negative ions, because for every positive you need to have a negative ion. So these easily gain electrons to attain a stable outer electron configuration. They are called anions. And the way that you are going to name your negative ions is you're going to take the root word. So for example, chlorine. Oh, I have it on the bottom.
Nice.
Chlorine.
You knew that.
Is a neutral atom. But when you lop off the end, okay, you take off the INE, then you replace it with an IDE, and now you're representing it as an ion. So let's take another one.
Fluorine.
Fluorine. That would be fluoride.
Sulfur.
Sulfide.
This is fun. Nitrogen.
Nitride.
Nice.
Now that one's really important, nitride, because later on in this chapter we're going to get into nitrates, nitrites, and then you've got nitride. You have to be able to identify which one it is based on the ending of the word. So you may think, oh, it doesn't matter if I put a T in there. Yes, it does. It means something completely different. So you need to make sure that your anions, if they're a single atom, and an IDE.
All right.
Okay, example of an anion. We've got chlorine. Chlorine is in the 3rd energy, or 3rd period. So it has 3 energy levels, and it has 6 in the P, reverse. We've got 7 electrons.
Oh, yeah, 7.
7 valence electrons. Okay, let's show you right here. Where's my mouse?
You're up in that one.
Oh, yeah. This one, 7 valence electrons. So it is missing 1. It needs 1 more to make it stable. So if you look at argon, argon is also going to have 8 in its outermost shell.
Okay.
Chlorine wants to resemble it, so the chloride ion has 8 valence electrons. the electron configuration goes from 3p5 now to 3p6. And
Okay.
now notice it's in brackets and it has a negative. That's how you represent an anion if you're going to draw the Bohr diagram of it.
Okay, so your cations, when they lose their outer shell, they're going to become the noble gas above them.
Yes.
And then the negatives, when they gain a negative charge, they're going to become the noble gas within the same row.
Right.
Okay.
Yeah, so chlorine is going to look like argon. However, magnesium is going to look like neon, even
Okay.
though they're both in the same row.
All right.
Okay, valence electrons. You may already know these valence electrons. The middle
should.
group in the D block, these are your transition elements. They are variable.
They're the goofballs I
Yeah.
like to call.
So your group 1, that has one valence electron. So that's the one that starts with hydrogen. The one that starts with beryllium, yes, is group 2. They have 2 valence electrons. Boron has 3. Carbon has 4. I got it.
Okay.
Nitrogen has 5. Oxygen has 6. Fluorine has 7. And your noble gases are going to have 8. The only one that does not have 8 for your noble gases is going to be helium,
Oh, I'm so going to put that on a test.
because it only has 2 electrons.
That's
It cannot
so
have
gotta be
8
on there.
valence.
Nice.
Okay? So all you have to remember is 1 through 8.
Okay.
Here are some tips to remember. If it has less than 4 valence electrons, it will probably lose its electrons, forming a cation.
Okay.
If it has more than 4 valence electrons, it will gain electrons, forming an anion.
All right.
Now, 4 is a tricky one because it's right in the middle. So your carbon group, group 14, they can either gain or lose.
We typically won't even see them in this chapter.
Right.
They're going to wait for the next chapter of
For
covalent
covalence.
bonding.
Yes. Okay, so here's your chart. You need to fill in your valence electrons. So fill in 1 through 8 across the top, and then take note of where those are on your periodic table, and make sure that you know that the groups below them, they all have the same valence electrons.
Okay.
That D block, those are variable. Okay, your group numbers, I put in groups 1 through 18, and then I also put in your Roman numerals. You may notice you've got Roman numerals, and they say either A or B.
Yeah, and it just depends on your periodic table that you're going to be using. We'll discuss the difference between even the 2 periodic tables that you're using, between the giant one and
Right.
the little colored one that we gave you, so that we can see where the Roman numerals are, if it's an A, if it's a B, what those need to be, and how we're going to use those.
But notice your Roman numerals, regardless of whether they're A or B. Where is my thing? Notice this Roman numeral is 8. You've got 8 valence electrons.
Yep.
Roman numeral 7 valence electrons. Okay, so they match
Yep.
what your valence are. Now your oxidation charges, your first group, group 1, they are going to lose 1 electron, so they have a +1.
Okay.
Group 2, they're going to lose 2 electrons, so they've got a +2. Boron, they're going to lose 3 + 3, it goes all the way across. Your noble gases, they're happy. They do not want to gain or lose, so they have an oxidation or a charge of 0. I don't know where my mouse is. Sorry, you've probably got a yellow dot all over it. Fluorine, they're going to gain 1, so they've got more electrons than protons, they've got a -1.
Okay.
Fill these in, memorize them. It will save you a ton of time if you know them.
Definitely.
Transition metals, so these guys in the middle, they are going to form cations, and these electrons, we've talked about it in chapter 5 and 6, I think.
Yeah, 5, 6.
But, so this is your S block, your transition elements are here. So they are going to have your S's and your D's for their sublevels. You may, if you get down here, you may have F in there too. But for the most part, when you have an S and a D sublevel, the electrons you're going to lose are the ones in the S level, and that will create a 2+ charge. If you lose any that are in the D, you're going to have higher. You're going to have a 3 or higher charge.
Okay.
So multiple charges are listed on your periodic table with the element. So this one right here, they're in the bottom. They're just 2 little numbers. Those are the oxidation states, oxidation numbers.
Yeah, just look for your key on whatever periodic table you're using and look for oxidation state or oxidation number. And
Yes.
it should be on the front side of both things. You're just going to look for it. They'll be
So-
there to help you out.
Yes, and yeah, unless we tell you otherwise.
Yeah.
Okay, There are multiple charges, so you must designate the appropriate ion with Roman numerals. The Roman numerals go in parentheses. So you write the name of the element, and then you do parentheses, Roman numerals, and that is your oxidation number.
Okay.
So, for example, you've got iron, and it is Fe2 plus. Your charge is 2 plus, so you do iron, parentheses, Roman numeral 2, parentheses.
So it doesn't mean you're using 2 irons. It means the charge of iron is a 2 plus.
Yes.
And then we're
Figure out
going to
my
have
pen.
chromium with the Roman numeral 3. So that 3 means not that we have 3 chromium, that we have a
Are you
3
thick?
charge of chromium. Cr3.
No.
You did a circle. 3
Plus.
All right, then we've got our Mn, which is manganese.
Oh, why did I pick this one?
I don't know, but you're going to have to spell it.
Manganese. I was hoping you would. Manganese, right?
Yeah.
Okay.
We got a 4 plus charge, so we got to use a Roman numeral 4. There you go.
Okay.
So if it's found in that valley section where the D's are, where the transition metals are at, you always have to designate which Roman numeral are. There are a couple exceptions in this area. Zinc is one of them because zinc's charge is always a 2 plus. Silver is the other exception because it's always a 1 plus.
Mhm.
Those are the 2 exceptions that we will use a lot in class. There might be a
Right.
couple others, but those are the ones that we typically use a lot of.
Mhm.
That those you do not need to designate because they don't change. But if we look at everybody else, there's a couple, but for the most part, those are the main ones that you're going to have memorized.
Yeah, like manganese it can have a charge of 2, 3, 4, 6, or 7. So you
Which
got to
is-
tell me which one it is.
Fabulous.
Okay, let's practice ion charges. So all you need to do is practice how to write these things.
All right, so we're going to find the symbol.
Okay.
Calcium.
Ca. Oh, sorry. Ca.
All right, if we got Ca, we're going to look where it's at. It's in group 2, which means it's going to have a 2 plus charge.
It's going to lose 2 electrons, so it's a +2. Sulfide.
Oh, you kind of gave it away with the IDE in the name.
I sure did.
The IDE, you're going to look over on this side of your periodic table where the sulfur is, where your non-metals are, and sulfur is a 2 minus.
Yes, it has 6 valence electrons, so it wants to gain 2. Carbon.
Carbon is a C, and it's in the halfway point. It's in group 14, which means
Yes.
it has a plus or minus 4.
Sure do.
So we're going to have to do a plus or minus 4 because we're not sure what it is.
So you want me to do it like that? Ooh. And write another one?
Oh, you could do that, or I'd just put a plus minus over with each other.
Like that.
Yeah, that's
Either
mine.
way.
Yep.
Okay. Cobalt.
Now we got a CO. Well, cobalt's found in the middle, so we could have either cobalt 2 plus or cobalt 3 plus, but we didn't designate which one we were going to use here.
No, we didn't.
So we're going to have to write them both, I guess. All right.
Okay. Copper.
Copper 1s, we're going to write this one out because now we're writing the name that gave you the charge. So copper, and we're going to have to use a Roman numeral because copper's found in the transition goofy group.
But your
And
charge is
then-
right here. It's a 1. So you just need a Roman numeral.
Yay!
Right? Iron. Fe is iron, in case you didn't know.
I hope you know by now.
I hope so. Okay. Roman numeral
3.
3.
1, 2, 3. And your N kind of.
I know. It looks like 2.
We're just going to have to fix that.
Ah! Oh my gosh. It didn't
All
even
right.
fix.
Section 1 is over.
Yay!
We're done.
Where is it?